my dear students of class 7. I am Shantipriyo sir, going to discuss your science chapter 8, wind storms, atmosphere, winds and storms, that is cyclones, right? At first we know about atmosphere. What is atmosphere? A layer of gases surrounds the earth and retained by the earth's gravity, which is commonly known as air, is called atmosphere. That is atmosphere. What do we mean by atmosphere? A layer of gases surrounds the earth and it is retained by earth's gravity, is known as atmosphere, right? Now we know the composition of air. Composition of air means the constituent of air. Here nitrogen, oxygen, argon, carbon dioxide, some traces amount of water vapor, another inert gases like helium, neon, hydrogen also will present here. Now we give the value of different amounts, percentage by volume of a dry air, right? The composition of dry air by its volume, that is in accordance with its volume, will be that. That is, we write here, that is nitrogen, we write N2, nitrogen equal to 78.09%, right? Oxygen equal to 20.95%, right? Next হচ্ছে argon, air means argon, helium, neon, argon, krypton, xenon, radon. Here argon, air means argon, inert gas, and inert gas. Argon, the amount of argon will be 0.93%. Amount of carbon dioxide is 0.24%. Sorry, 0.04%, খুব minute amounts, right? And another gases also present. Water vapor, that is H2 actually. Water vapor, what is the amount of water vapor? Water vapor 1% to 0. How many amount? 0.4%, 0.6%, not 4% also, will be right. Another inert gases, neon, helium, methane, etc. are also present in small amount. Hydrogen, krypton, another inert gases. Neon, the amount of neon in percentage by volume will be 0.00181, approximately at percent. Helium, what will be the value of helium? Helium will be the 0.0005%, very minute amount. Methane, the amount of methane is 0.00018%, and amount of hydrogen will be 0.40, that is 4055% or 5% or 6%. Krypton is very minute amount, 0.0001114%, right? Atmosphere of air, that atmosphere, or simply we call it air, the percentage composition by volume of a dry air, is nitrogen equal to 78.09%. Write in your notebooks, exercise book. Nitrogen is 78.09%, oxygen is 20.95%, write it, 20.95%, 20.95%, argon 0.93%, and inert gas is carbon dioxide 0.04%, water vapor 1% to 0.6%. In the case of sea level, its value is 1%, and another entire surface of the earth approximately 0.4 actually 0.4%. That is lies between 1 to 0.4, 1 to 0.4%, right? Helium is, neon is 0.0018%. It is also an inert gas. Helium is also an inert gas. Its amount is 0.0005%. Methane is 0.0018%. It is an hydrocarbon, simplest hydrocarbon. Hydrogen is 0.00005%. It is also, methane is also called Mars gas. Krypton 0.000114%. Write in your notes books, exercise book, right? Now, we rush it. We know the different layers. The layers of Earth extends about 1200 kilometers. The first, that is the lowest layer with respect to the Earth, is called troposphere. Troposphere. In this layer, it extends from 0 to 12 kilometers with respect to the Earth's surface, right? Its temperature and pressure both are decreased with increase in altitude. Pressure for all layers will be decreased with altitude, remember it. But temperature in various layers may be varied, right? In the troposphere, which extends to 12 kilometers from the Earth's surface, contains dust, particle, vapor, water vapor, cloud, etc. Hence, in this layer, and also oxygen, carbon dioxide, nitrogen are present here. Water vapor also present. In this layer, thunderstorms, rainfall, etc. occur. Right? Now, troposphere, in the troposphere, since thunderstorms, that is thunder associated with storm, lightning, and here the temperature in this layer is decreased with increase in altitude. And at the top portion of this layer, the temperature becomes minus 56 degrees Celsius. Right? Remember it, 56 degrees Celsius. Minus 56 degrees Celsius. Since in this zone, airflow, that is winds, thunderstorms, etc. are occurred. Hence, this layer is also called angry layer. Right? Next, just above the troposphere, and then next layer will be stratosphere, which is from 12 kilometer to 45 kilometer. That is, stratosphere extends up to 45 kilometer from 12 kilometer with respect to the Earth's surface. And in between the troposphere and stratosphere, a thin layer, that is at the junction, a layer is present in which the temperature does not depend upon the altitude. The temperature remains constant. This layer is called tropopause, right? This layer is called tropopause. That is troposphere and stratosphere, in the junction of troposphere and stratosphere. Now, we discuss about stratosphere. Stratosphere, already mentioned that it is extended from 12 km to 45 km with respect to the earth, right? Hence, here the temperature, pressure will be decreased in all the layers with altitude. Here temperature will be increased. Here temperature will be increased, right? Now, in this layer, that is stratosphere, here a layer of ozone gas is present. It extends from actually 16 km to 30 km within the stratosphere. Hence, sometimes this layer also called ozonosphere. Remember it. Here, no cloud or thunderstorms be occurred, because in this layer the amount of moisture, air particles, etc. are negligible. We may be neglected them. For this reason, no, and in this layer, amount of oxygen is also minute, so taking breath is also difficult. We cannot survive in this layer without carry oxygen cylinder. Next, here we have, this is a quiet zone also, because no thunderstorms occur in this case. Hence, stratosphere is also called quiet zone, right? In this layer, we have already mentioned ozone layer is present. No cloud, obviously. Next, we have and no change in some layer above the stratosphere, a layer, stratosphere and mesosphere, in which temperature remains constant, that is, does not change with altitude. This is called stratopause. This is called stratopause, right? Now, now we have the third layer known as mesosphere. Mesosphere extends from 45 km to 85 km. Mesosphere is the coolest layer of all the, on comparison of with the other four layers, right? It extends from 45 km to 85 km with respect to the earth. In this layer, temperature decreased, and just at the bottom of this layer, temperature decreased to minus 92 degrees Celsius. In this layer also, some amount of nitrogen, oxygen, NO plus, O2 plus and NO plus also present. N2O2, O2 plus, NO plus also present in this layer. This is the mesosphere, right? Now, we know the next layer. In between mesosphere and thermosphere, next layer is thermosphere. In between mesosphere and thermosphere, a layer of air is obtained, whose temperature does not change with altitude, and this layer is called mesopause, right? This layer is called mesopause. This layer is called mesopause. Now, we discuss about thermosphere, mesosphere and thermosphere. Mesosphere already mentioned, already discussed. That is the junction between mesosphere and thermosphere, in which temperature remains same, is called mesopause. It is already discussed. Now, thermosphere. Sometimes it is also called ionosphere because in this layer air molecules are in ionized state. In this layer temperature increased and with altitude, but pressure always decreased. Temperature increased up to 1200 degree Celsius. Here almost no air, hence breathing is very difficult, right? It extends from 85 to 500 kilometers with respect to the Earth. In this layer, that is thermosphere layer, polar lights are seen. Polar lights or polar light is seen, right, in this layer. Now, we have the last layer, exosphere. Exosphere is extend from 500 kilometer to about 1000 kilometer with respect to the Earth. In this layer, some traces amount of hydrogen, helium gases are present. Exosphere. In exosphere, artificial satellites, space stations are located. Right? Now, first three layers, according to their chemical composition or structure, first three layers is called homosphere. That is the troposphere, stratosphere and mesosphere altogether are called homosphere. And the last two layers of air is called heterosphere. That is thermosphere and exosphere are called heterosphere. Right? These must be remembered you. Right? Now, we may say that in the stratosphere, right? In the stratosphere, airplanes are moved, right? Remember this. We rush it. Now, we know about wind. What do we mean by wind? Wind. Wind is a flow of air in a massive amount, in a large scale amount, moving gases, that is air here, air, moving gases or airs in the Earth's surface, obviously in the troposphere, not stratosphere, in the Earth's surface, in the Earth, in the layer, atmospheric layer of atmosphere. That is troposphere. Troposphere. In a large scale. In a large scale is called wind. Moving gases, that is airs, in the layer of atmosphere, that is troposphere, in a large scale is called wind. This is called wind. Right? Hence, wind is defined in this way. Now, we discuss about the formation of wind. Why wind is formed? We know it, right? We know it. Right. Formation of wind. Cause of formation of wind. Cause of formation of wind. Cause of formation. Cause of formation of wind. What is the cause of formation of wind? It is due to the difference in temperature, consequently difference in pressure of airs. Right? In the case of that is uneven temperature. Main cause is uneven temperature. Uneven temperature in the atmosphere. Consequently, temperature difference temperature difference temperature difference in air, in different layers of air, in air, we write it in layer, in air, is the main cause, is the main cause of the formation of wind, right? Uneven temperature in the atmosphere, consequently temperature difference in air or temperature difference creates pressure difference in air is the main cause of the formation of wind. We discuss it in the following way. Right? To write this, let us consider the two regions, that is equator, this is the earth, this is equatorial plane, and this is polar region, poles, North Pole and South Pole. This is equatorial plane. Now, Earth moves in this way. This is east, this is west, right? East, west. In this way, here, if we consider the sun rays coming from sun, different rays, ultraviolet rays, infrared rays, etc. At the equatorial region, that is equatorial region near the equatorial region, and at the poles. Poles are at a large distance in comparison with the equator from the sun. So, pole is of lower temperature than the equatorial. Its pole is cold, but equator, at equator region, the temperature is high. So a temperature difference creates here. And for this reason, the air at the poles being cold and hence heavier than the air at the equatorial region. In this region, air becomes hot and hence it becomes lighter and rises up. And hence an empty space is created at the equatorial region. And it is in the lower pressure because here air rises up. So a temporary vacuum is produced. Hence, from the high pressure region, that is from the pole, from the pole, the air rushes towards the equatorial region. Hence, here actually air flows from high pressure to low pressure from the pole to the equator, right? But since the earth rotates, the direction of the wind or a flow of air is not along the North Pole direction. Remember it. Right? The speed of wind is measured by what is the measurement, how you measure wind speed, we measure wind speed, and how we get its direction. Remember them, right? Remember them. What is the how is the direction is measured? By which device? The device is named as the wind vane. Remember it. Wind vane. This device measures the direction of airflow. That is wind. Airflow or wind. Wind vane. This device measures the direction of air flow. It gives direction. But how wind speed is measured? Anemometer. Anemometer is a device which is used, anemometer is a device which measures speed of wind or air flow. Speed of wind. Hence, anemometer is a device, that is anemometer is used for the measurement of speed of wind. Anemometer is a device used for the measurement of wind speed. In the another cases, that is the winds blow from ocean to land or vice versa. We give it in the next portion. That is another cause. We know it is already discussed that during daytime, Earth's surface becomes, that is land near ocean, becomes hot quickly, but air above the ocean water is not heated up quickly. It takes more time because specific heat of water is greater than that of the land materials. What do you mean by specific heat? Specific heat is the amount of heat required to raise the temperature of a body through 1 degree Celsius. Through 1 degree Celsius, right? Remember this H, that is the amount of heat, M, S, and rise or fall in temperature. That is, if heat is gained, then this is rise in temperature. If heat is lost, this is decrease in temperature. Okay, this is the specific heat. MST, this is the specific heat. Right? Specific heat. H equal to MST. M multiplied by S and multiplied by T. That is temperature. Sometimes you write it as delta T, del T. Right? Here S is specific heat. Hence, if M1 T1, then H equal to S. That is, the specific heat of a substance is defined as the amount of heat required to unit mass of a body through 1 degree temperature, rise or fall in temperature, right? M1 D1, M1, if M1 T1, then H becomes S, equal to S. That is, the rise in temperature of unit mass of a substance through 1 degree, maybe 1 degree Celsius, 1 Kelvin, etc. Mass may be gram, kilogram, etc. is called the amount of heat required to rise the temperature of unit mass, that is 1 gram or 1 kilogram mass through 1 degree Celsius or 1 Kelvin, is called specific heat in CGS and SI systems respectively. But specific heat, actually from another definition we have, it is no unit. It is the ratio of two similar quantities, physical quantities. Now, in the night time, that is, in this case, land becomes quickly, here ocean, above ocean, sea or ocean, above ocean the air becomes hot and lighter, and hence a pressure difference is created between the land and the ocean. In this case, land being at high pressure than sea, ocean, air above ocean surface, above ocean, hence here air blows from land to ocean, and it is occurs at night. It is called land breeze. Right? It is already discussed. Now, main things is at the daytime. Main things is the daytime. In this time, land becomes quickly heated up due to its low specific heat of the materials on the land, formation in the land, that is, land constitutes materials have low specific heat than water. So in this case, land becomes quickly heated up than water in the ocean, and hence air above the ocean is comparably cool than the air above the land. Hence, in this case, air above the land becomes lighter, being heated up, and moves upwards. But being cool air above the ocean, it has high density, that is at a high pressure. The air from the ocean rushes towards the land, and this is called sea breeze, which occurs at daytime. Sea breeze gives us a lot amount of water vapor or water from the ocean, and hence in a seasonal way we have monsoon wind. This wind is called monsoon wind. Remember it. This is very important for us, for irrigation, etc. Is essential for the development of plants, etc. Water is essential for the nutrients, etc. Right? Now, cyclone. What do you mean by cyclone? Remember it. Cyclone is a actually storm with high speed. With high speed. Remember it. With high speed are blown above the surface of the earth. Remember it. Here the cyclone has a high speed wind, and it has a central part, central or central region, which is the eye, actually at very low pressure. It is called eye. The center portion of the cyclone is called eye. It is called eye, right? Eye is during formation, it is at stationary state, but it moves with the cyclone ultimately, and the speed formation of a cyclone is about 200 km per hour or more. It is a dangerous effect for this. Various names are given for cyclone: hurricane, tornado, etc. In the case of, we know that typhoon is named in the Philippines region, and hurricane is at the different American countries are formed as hurricane, right? Remember that. Now, during thunderstorm, that is thunder associated with storm, it's called thunderstorm. During thunderstorm, some precautions must be written. That is, we don't stay under the big tree or open house, etc. And in this time, we don't lie on the earth's surface. It is also essential. Some precautions must be taken for this purpose to save life. And for the cyclone, we must be take shelter in a house which is made for that tremendous speed of cyclone, so that it cannot blown up. Right? Remember it. Now, some questions are discussed from your book. What is dash is a mixture of gases. Dash is a mixture of gases. What will be the answer? Answer will be air. Air is a mixture of gases. Air is not a compound. It is a mixture of gases. Next, the layer of air above the earth is called, the layer of air above the earth is called atmosphere. Atmosphere. And it is divided into 5 layers, that is troposphere, starting from troposphere, stratosphere, mesosphere, ionosphere or an exosphere. ঠিক আছে, right? Right? Ionosphere or thermosphere also. Air dash on cooling and experts on dash. Air dash on cooling and experts on dash. Air contracts on cooling. That is, if it is cool, its volume will be decreased. And expands on heating. That is, on heating, its volume will be increased. Right? Hence, the answer will be air contracts on cooling and expands on heating. Next, high speed winds are accompanied by air pressure. High speed winds are accompanied by huge pressure. Next, we have some questions. Moving air is called dash. Moving air is called dash. Right? Moving air is called wind. Warm air is dash than cold air. Warm air is lighter than cold air. Remember it. The instrument used to measure the speed of wind is called, the speed of wind is measured by the anemometer. What will be the spelling? A-N-E-M-O, anemo, A-N-E-M-O-M-E-T-E-R, anemometer, A-N-E-N-O-M-E-T-E-R. Anemometer is a device used for measurement of speed of wind. Right? Next question, very short answer type question. Why are equatorial regions of the earth very hot? It is already discussed. Since it is at a lower distance than polar region from the sun, hence it is heated up quickly. What is a thunderstorm? Thunder associated with storm and lightning is called thunderstorm. What are monsoon winds? Already mentioned. Monsoon winds are the seasonal winds when in the daytime land becomes lighter than ocean, air above ocean, and hence air above ocean being cold, having high density and high pressure, so it rushes toward the land, which carry a tremendous amount of water, that is water vapor, on the lands, and hence heavy rainfall, sometimes heavy rainfall occurs. This is called monsoon wind, monsoon winds. Why do tornado occurs frequently? Especially in the America, that is United States of America, in that region, and also in some of the regions, another regions also have obtained it. Next question. USA and Canada will be an answer. Next question. Explain why holes are made in banners. You see that in a banner some holes are given. This is because if holes are not given, what happens? During the wind blows on the banner, it has high pressure, it gives high pressure on the banner, and hence the banner may be torn out or may be grounded. To avoid this, we make some holes on the banner so that air passes through it and the pressure given by wind is somewhat becomes low, and hence banner is not in not fallen or torn out, right? Next question: why are ventilation of our houses located near the roof? You see that ventilation of a room is located near the ceiling, right? You see, near the ceiling. This is because when we located at house, then during breath carbon dioxide is released and it is hot, so that these hot gases is expelled from the room, hence they move upwards and then they go out from the house. It is also a reason, or any other gas formation in a room, they will be escapes out from the ventilator. Now, it is already mentioned what is atmosphere, what causes atmospheric pressure. Atmospheric pressure, cause of atmospheric pressure, we know the air surrounding the earth has a weight, and it is approximately 5.5 into 10 to the power 18 kilogram, right? This huge weight of air, when the weight of air of a column of air vertically exerted on unit area, surface area of the earth gives air pressure. This is called air pressure. And if it is taken, that is air pressure is taken at the sea level at 0 degree Celsius temperature and 45 degree latitude, then the 76 centimeter of mercury column air will be the standard atmospheric pressure. Standard atmospheric pressure is 1.01325 into 10 to the power of 6 dyne per square centimeter, or 1.01325 into 10 to the power 5 Newton per meter square or Pascal. Remember, in the next class we explain another questions and start the new chapter, right? Okay.